Have you ever wondered if quantum computing, this seemingly abstract concept, is the future or just another tech buzzword? If you have, then you are not alone. In the world of information technology, no other topic draws as much fascination, and at the same time, skepticism, as quantum computing. So, what is quantum computing? In the simplest terms, it's an area of computing that utilizes quantum mechanics, a branch of physics that describes the bizarre behaviors of the smallest particles in the universe. Traditional or classical computers operate on bits that are either in a state of 0 or 1. Quantum computers, on the other hand, use quantum bits or qubits, which can be both 0 and 1 at the same time, thanks to a quantum quirk called superposition. This striking difference allows quantum computers to process a massive amount of information at once. Imagine being able to solve complex problems in seconds that would take a classical computer thousands of years to crack. That's the promise of quantum computing, but with such potential comes hype, and lots of it. There's a buzz in the air that quantum computing is the next big thing, the revolution that will change everything in our digital world. But is it really? Or is it just a bubble waiting to burst? There are questions, many questions. Can quantum computers really deliver on their promises? Are they practical for everyday use? What about the challenges in building and maintaining these machines? And most importantly, when will they become mainstream? These are not easy questions to answer. Quantum computing, after all, is a field that's still in its infancy, a field that's as complex and mysterious as the quantum mechanics it's based on. But that's what makes it so intriguing, so tantalizing. It's a puzzle waiting to be solved, a mystery waiting to be unraveled. As we delve into this topic, we'll attempt to unravel the mystery of quantum computing and its potential. Join us on this journey as we explore the fascinating world of quantum computing, its power, its applications, its challenges, and its future. So, what exactly is quantum computing, and how does it compare to the computers we use today? Quantum computing, in its simplest terms, is an area of computing focused on developing computer-based technologies centered around the principles of quantum theory. Quantum theory explains the nature and behavior of energy and matter on the quantum, or atomic and subatomic level. To understand quantum computing, let's first take a look at classical computing. Classical computers, which include the laptops and desktops we use daily, encode information in binary bits. Each bit can either be a 0 or a 1. They are like the on and off switches that control the flow of electricity. Quantum computers, on the other hand, use qubits. Unlike bits, which are firmly a 1 or a 0, qubits can be in a state of 1, 0, or both at the same time. This is due to a quantum theory principle known as superposition. Imagine a sphere. On a classical computer, a bit would be at either of the two poles. However, a qubit, thanks to superposition, can exist at any point on the sphere. This means that a computer using qubits can store an enormous amount of information and use less energy doing so than a classical computer. Another quantum principle at play here is entanglement. Particles that have interacted with each other become entangled, meaning the state of one particle is directly connected to the state of the other, no matter how far apart they are. In terms of computing, this allows qubits that are entangled to work together, providing quantum computers with an incredible amount of processing power. Quantum computing holds the promise of solving complex problems much more quickly than classical computers. But it's not about replacing them. In fact, quantum computing is expected to operate alongside our classical computers to solve specific problems that are currently beyond their reach. In essence, quantum computing takes advantage of the strange ability of subatomic particles to exist in more than one state at any time. But why should we care about quantum computing? What makes it so powerful? Well, let's dive in. First off, quantum computing has the potential to solve complex problems that classical computers, even the most advanced ones, could take ages to crack. This is because quantum computers use quantum bits, or qubits, rather than the binary bits of classical computers. While a binary bit can be either a 0 or a 1, a qubit can be both at the same time, thanks to a quantum quirk called superposition. This allows quantum computers to process vast amounts of data simultaneously, making them enormously powerful and fast. Imagine trying to find a needle in a haystack. A classical computer would sift through the haystack one straw at a time, but a quantum computer, it could look at every straw at once. It's like having thousands of search parties combing through the haystack at the same time. The needle gets found much faster. And then there's entanglement, another quantum peculiarity. In entanglement, pairs of qubits become intertwined such that the state of one instantaneously influences the state of the other, no matter the distance. This leads to an exponential growth in computational power. For instance, 50 entangled qubits could represent over 1 quadrillion values simultaneously. That's a number so big it's hard to wrap your head around. This immense processing power makes quantum computing a game changer for fields that deal with massive amounts of data. It has the potential to revolutionize drug discovery, climate modeling, financial modeling, and artificial intelligence, among other things. It could also crack encryption codes that are currently unbreakable, leading to a new era of cybersecurity. So, why should we care about quantum computing? Because it's set to redefine what's possible in computing, and in turn, transform our world. Imagine a future where new medications get discovered in mere minutes, not years. That's the power of quantum computing. Quantum computing isn't just theoretical, it's already making waves in various industries. First, let's dive into the healthcare industry. Quantum computers, with their ability to process and analyze vast amounts of data in the blink of an eye, could revolutionize drug discovery and genomic research. Imagine a world where personalized medicine is the norm, not the exception. A world where doctors can prescribe medicine based on a patient's individual genetic makeup, drastically reducing side effects and improving treatment outcomes. That's the promise of quantum computing in healthcare. Next, we venture into the realm of finance. Here, quantum computers could be game changers in risk management and investment strategies. They could help banks and investment firms optimize their portfolios, evaluate risk more accurately, and make more informed decisions. This could lead to a more efficient and stable financial system, benefiting everyone from Wall Street traders to everyday savers. Artificial intelligence is another field where quantum computing could make a significant impact. Quantum computers could accelerate machine learning, a subset of artificial intelligence, by performing complex calculations at speeds unimaginable today. This could lead to more powerful AI systems capable of solving problems that are currently beyond our reach. In the field of logistics and supply chain management, quantum computing could optimize routes and schedules, minimizing costs and reducing environmental impact. Imagine a world where your packages arrive faster, your favorite products are never out of stock, and companies operate in a more sustainable way. This could be the future with quantum computing. Finally, let's consider cybersecurity. Quantum computers could potentially crack encryption codes that are currently unbreakable, posing a serious threat. However, they could also help us create new, more secure encryption methods, leading to a safer digital world. These are just a few examples of how quantum computing can reshape our world. Despite its potential, quantum computing is not without its challenges. Quantum computing is a revolutionary technology, but it's not without its fair share of hurdles. One of the primary challenges lies in the technological aspect. The qubits, the fundamental units of quantum information, are notoriously tricky to manipulate. Unlike classical bits, which are either 0 or 1, qubits can be both at the same time, thanks to a quantum phenomenon known as superposition. This makes quantum computing exponentially more powerful, but it also makes it much more difficult to control. Another major obstacle is the need for extremely cold environments. Quantum computers need to be kept at temperatures near absolute zero to function efficiently. That's colder than outer space. This is because any heat in the system can introduce errors by causing the qubits to change their state, a phenomenon known as decoherence. Keeping these machines cold enough to operate correctly is a daunting task, and it's one of the reasons why quantum computers are still largely confined to research labs. Error correction is another significant challenge. Due to the delicate nature of qubits, they are susceptible to errors. This is exacerbated by the fact that quantum information cannot be copied due to the no-cloning theorem, a fundamental principle of quantum mechanics. This makes the traditional error correction methods used in classical computing ineffective in the quantum realm. Scientists are still grappling with how to correct errors in quantum computing, and it's one of the most active areas of research in the field. In addition, there's the issue of scalability. Building a quantum computer with just a few qubits is a monumental task. Now imagine scaling that up to the millions or billions of qubits necessary for practical everyday computing. It's a bit like trying to build a skyscraper out of playing cards. These challenges remind us that while quantum computing holds great promise, it's still in its early days. So as we marvel at the potential of this exciting technology, let's also remember the work that still needs to be done. It's a fascinating journey, and we're just at the beginning. So, what does the future hold for quantum computing? Is it going to revolutionize our world? The answer to that question is complex. Quantum computing, with its incredible processing power and potential to solve problems that are currently beyond our reach, certainly has the potential to shape our future in ways we can't fully predict. Imagine, for instance, the world of medicine. Quantum computing could revolutionize drug discovery, helping us find cures for diseases that have stumped us for decades. With the ability to process vast amounts of data at unprecedented speeds, we could see breakthroughs in personalized medicine, tailoring treatments to each individual's unique genetic makeup. In the field of cryptography, quantum computers could both pose a threat and offer a solution. They have the potential to crack codes that would take today's strongest supercomputers centuries to break. However, they could also lead to the development of new quantum-resistant encryption techniques, ensuring our digital security in a post-quantum world. Climate change, one of the biggest challenges of our time, could also benefit from quantum computing. It could enable more accurate climate modeling, allowing us to predict and understand climate change better. This could lead to more effective strategies to combat global warming and its effects. Even our everyday lives could be impacted. Quantum computing could revolutionize the way we search the internet, making search algorithms exponentially more efficient. Or consider transportation. Quantum computers could optimize traffic flows in real time, reducing congestion and making our commutes smoother. Of course, these are just possibilities. Quantum computing is still in its infancy, and it will be years, if not decades, before we see its full potential. There are significant technical challenges to overcome, and it's not yet clear what the ultimate impact will be. While it's still too early to say for sure, one thing is certain: quantum computing has the potential to change the world as we know it. Before we wrap up, let's revisit the key points about quantum computing and its potential. Quantum computing, it's a term that's been buzzing around for a while now. But what is it really? It's a new type of computation that uses quantum bits, or qubits, instead of the binary bits we're accustomed to in traditional computing. This gives quantum computers the ability to handle vast amounts of data and solve complex problems at a speed that's beyond the capabilities of even the most powerful supercomputers today. In essence, quantum computing is about harnessing and exploiting the strange laws of quantum mechanics to process information in ways that are not possible with classical computers. The potential of quantum computing is enormous. It could revolutionize various industries, from medicine to finance and beyond. For instance, in medicine, it could help in drug discovery and genetic research, enabling the development of personalized treatments. In finance, it could optimize trading strategies, enhance risk management, and improve data security. And let's not forget about its potential applications in artificial intelligence, where it could speed up machine learning algorithms, paving the way for more advanced AI systems. Yet, quantum computing is not without its challenges. The technology is still in its early stages of development, and there are several technical hurdles to overcome. Qubits are highly sensitive and require extremely cold environments to function, which makes them difficult to scale and prone to errors. Moreover, quantum algorithms are complex and require highly specialized knowledge to develop. These challenges, while significant, are the focus of intense research and development efforts across the globe. Another critical aspect to consider is the ethical and societal implications of quantum computing. The power of this technology could also be used maliciously if it falls into the wrong hands. Therefore, it's crucial to develop robust security measures and ethical guidelines alongside the technology itself. Despite these challenges, the future of quantum computing looks promising. Major tech companies and research institutions are investing heavily in this field, and we're seeing continuous advancements. Quantum computers are becoming more stable, more powerful, and more accessible. As we move forward, we can expect to see quantum computing integrated into our everyday lives, reshaping the way we solve problems and process information. In conclusion, quantum computing is more than just hype. It's a groundbreaking technology that could redefine the limits of computation and unlock new possibilities across various sectors. However, it's also a complex and challenging field that requires concerted efforts in research, development, and ethical considerations. Quantum computing may sound like science fiction, but it's becoming more of a reality every day. It's a fascinating field that we should all keep an eye on.